Hello students, how are you? Fine, good. All right, I know you students of North Georgian Secondary School. Do you love being at North Georgian Secondary?
Yes, sir.
All right, good. And I hope that you guys will perform excellent in your mathematics test. Regardless of what mathematics test you have to do at North Georgian Secondary, you will perform excellent in that test. Great?
Yes, sir.
All right. Today we're going to continue our series of mathematics classes for grade 8, and we will look at a particular topic. The topic is ratio. Some person smiling, like you heard of that topic before.
Yes, sir.
Okay. Yes, the topic of ratio we will be looking at. Some of you did this topic before?
Yes, sir.
All right, but you know that's the beauty about mathematics. In mathematics, we will, for example, do addition. We will do addition from primary 1 all the way to primary 4, and you're still doing addition. When you go to secondary school, you still have to do addition, but what happens to the problems, the types of problems that you get? Yes, it gets harder and harder. So we will be looking at ratio, and even though I know some of you did ratio before, our ratio problems now will just get a bit more difficult. And I hope that you are prepared to deal with the difficult problems that you will be given today. Do you think you're prepared?
Yes, sir.
All right. Well, I hope that by the end of this lesson, you will be well prepared to deal with any ratio problem, because I know you students will be the next set of mathematicians coming up. I see somebody smiling at the back there. You're going to be the next mathematician coming up? All right. Now, what is ratio? Ratio refers to expressing two quantities as in a relationship. Or we can say ratio refers to the relationship between two quantities. So, for example, you may want to know, okay, you may have two containers of water. You may have a small bucket and you have a drum. And then you might want to express the amount of water in the two quantities. All right, to show what is the relationship, how are they related in what way? Okay? So you may say, okay, the bucket has 10 liters of water, but the drum has 200 liters of water. And then you might want to know, you might want to answer certain questions too. Like, how many of the buckets full with water will fill the drum? You might want to answer certain questions, and we can use ratio in a variety of ways to help us to do that. Additionally, we can use ratio in helping us to share certain quantities. Because if you have a basket of mangoes, and you want to share this mango, let's say you want to share the mango between myself and Shaquille. We're going to share the mango between myself and Shaquille. But for every 5 mango I collect, I give Shaquille 2. That sounds fair, huh?
No.
It doesn't sound fair?
No.
Okay, let's say for every 3 mangoes I collect, I give Shaquille 2. Sounds better, right?
No.
All right, every 2 mangoes I get, I give Shaquille 3. All right. Well, you see, but we can share things. If we want to be exact, well, then we will say, for every 1 that I receive, Shaquille also take out 1. And then we know everybody going to get the same amount. But then if I say, for every 5 that I get, I give Shaquille 2, it means I'm going to end up with much more. Do you agree?
Yes,
or if I say,
sir.
for every 2 that I collect, I give Shaquille 3, well, then he's going to end up with much more than me. So we can see if you have a set of things to share, well then we can, if we know in what ratio we're going to share it in, right? How are these 2 numbers associated? Well then we can share it evenly. Now imagine you, and if you have a brother or sister, and your parents give you some money and say, look, share this money between the 2 of you. I know if it is a little sister you have, you wouldn't want for that even sharing them. Huh? Donika smiling. Donika wouldn't want to give her, if she has $1,000, she wouldn't want to give her little sister 500 and she keep 500. She might want to say, 7 for me, 3 for you. All right? So she might want to share it like that. So when we speak about ratio, we're looking at some form of relationship between the numbers, or we may look at the comparison between the 2 numbers. How can we compare these 2 numbers? So for example, Let's look at some examples. If we have example A, if we have 3 cm and we wish to compare 3 cm to 15 cm, we can compare these two, right? We can compare 3 cm and 15 cm. If you have an idea what 3 cm is, it can help you to determine what 15 will be. You can compare it. Let us look at another example. Another example could be you can have, let us say, you have 20 grams and you want to compare 20 grams to, let us say, you have 1 kilogram. Now, question. Observe here, we are comparing these two, but both of them were speaking about the same thing. Both of them were speaking about cm. But in this case, we are attempting to compare two quantities that are not of the same type, because one is gram and one is kilogram. But in ratio, when we're going to compare quantities, we compare quantities of the same type. Is that clear?
Yes.
We compare quantities of the same type. So what we have to do, we have to express this 20 grams and the 1 kilogram as one type. So we will not have grams and kilograms. If you're going to deal with grams, it is strictly grams. If you're going to deal with kilograms, then it is strictly kilograms. Now, anybody can recall how many grams make 1 kilogram? How many grams make 1 kilogram? Kilo. Come on, you always use this word kilo steady, man. Or you never hear persons refer to, for example, the year Y, let's say Y2K, y'all never hear about these things? What K means when we see the word K? What it means? 1,000, good. So we know what K means. K means 1,000. So if we have kg, what do you think kg means?
1,000.
1,000 grams, correct. So when you see these things, it shouldn't be difficult for you to understand what it means. K means 1,000, so kg means 1,000 grams. So if you have 1 kg, it is saying that you have 1,000 grams. If you have 10 kg, how many grams you have? 10,000 grams. Is that clear?
Yes.
So, to better compare these here, well then we can write it as 20 grams to 1,000 grams. Now they are of the same type. So that's the first thing. Any problem you have in comparison in ratio, you must express them as the same type. There is a special symbol though that we use in comparing in ratio. And I know somebody must know this symbol. So rather than saying 3 cm to 15 cm, and we're spelling out this word too, rather than saying 20 grams to 1,000 grams, there is a symbol that we use to replace this too.
2 dots, right?
2 dots. So what we call it? A colon. Good. We use 2 dots or a colon. So the symbol we use for ratio is 2 dots. So for example, instead of saying 3 cm to 15 cm, we can then say 3 to 15, and we're in terms of cm. So we can just say 3 to 15. Remember, that's what mathematics is about, making things easy. So rather than spelling out and writing out all of this, we just write 3 to 15. No, we're not speaking the time here. This is not 3:15 we're talking about, right? So it's not 3:15. We're talking 3 to 15. And then, for example, this 20 grams to 1,000 grams can be written as 20. We can write as 20 grams, colon, 1,000 grams. Or we can just write it as 20, colon, 1,000, if we know that we are talking about grams. Now, we come to the question of reducing the ratio. Reducing a ratio to its simplest form. Do you know how to reduce fractions? how do we reduce fractions? Let's look at how we reduce fractions. If you have this fraction here, let us say you have the fraction 20 divided by 35. And we want to reduce that fraction. How do we reduce it? We look for a number that can divide both of them. And such a number is called a factor. So we want a factor for 20 and a fact that is also a factor for 35. And because it is a factor of both of them, we call it a common factor. So we're looking for a common factor. All right? So just a fancy name for what you said. You said a number that can divide both of them. But a fancy name for that is a common factor. You know, as mathematicians, we got to use the mathematics words, right? So we're looking for a common factor. And a common factor is?
5.
5. Perfect. 5 can divide 20. How many times?
4.
So if we divide this by 5, we get 4. If we divide 35 by 5, we get
7.
7. So we can say that 20 divided by 35 is equal to 4 over 7. So this is how we can reduce fractions. The same approach is used for reducing ratio. So if you express a quantity as a given ratio, then we can reduce it in similar ways. So let us see. Look at the two examples which we have here. And let us start with the first one. We have 3 to 15. Is there a common factor of 3 and 15?
Yes.
What is that common factor?
3.
So we would want to divide. Divide here by 3 and divide here by 3. 3 into 3?
1.
1, colon. 3 into 15?
5.
5. Perfect. So what we can say is 3 to 15 is the same as 1 to 5. Is that clear?
Yes, sir.
So tell me, 20 to 1,000, what will that be? 20 to 1,000. What will this be equal to? Take a few seconds and do it quickly. 20 to 1,000. And tell me what it will be equal to. I will come back to you for the answer. Someone is already ready, having the answer to give. Remember, we first have to find this common factor, this number that can divide both 20 and 1,000. All right then, let us see. Which number can divide both of them? Any number. Which one? 20 itself. So you start with the biggest number that can go into both of them. Of course, that is the easiest way, but just in case you cannot identify 20 as being the number which could divide both of them, well then you can also start with a smaller number. For example, 2, you might start with 2. And you might say 2 into 20 will give me 10. And 2 into 1,000 will give me 500. But then you realize 2 could divide them again. So you say 2 into 10 is 5. And 2 into 500 is 250. And then we say 5 and 250, 5 can divide both of them. So then we would want to say 5 into 5 is
1.
and 5 into 250 is 50. Or, as you said previously, we could just look at this and divide both of them by 20. And it will give us 20 divided by 20 is 1. And 1,000 divided by 20 is 50. So 20 to 1,000 is the same as 1 to 50. Now I have a puzzle to solve now. And I would like for someone to solve this quickly for me. Here is the problem. I thought you solved it already. Yes. What is that number that should go into that box or replace that box? If 15 to 9, yes, Donika?
8.
Danica is saying
18.
18. Danica is saying 18 must replace that. 15 to 9 is equal to 30 to 18. Correct. How we get 30 to 18? What we do, we check to see what did we do with 15 to give us 30. And what did we do with it? We add it to itself once, or we could say you multiply it by 2. Multiply this by 2 to give us 30. So then we also multiply the 9 by 2 to give us 18. All right, try another one. Danica is ready again to answer. Yes, what is the answer? 6. She's saying 6 is her answer. Anyone agree with 6?
Yes, sir.
Anybody disagree with 6? What do you think about me? Do you think I agree or not?
Agree.
You think I agree?
Yes, sir.
And if I disagree, well, then it means you guys are wrong.
No, sir.
Well, then what it means if I disagree? Who's wrong then?
You, sir.
I'm wrong?
Yes.
I like your confidence. Yes, because this is correct. Let us see. We have something to 8 is equal to 12 to 16. We have one part here, so we can see what is the ratio between 8 and 16.
8 times 2.
8 times 2, or we could say 8 is half of 16. So therefore means this number here must be half of 12, which is 6. Correct. Good. So we have those correct so far. So we can establish relationships like that. So because we know to establish relationships like that, it means that I'm excited about this next question that I'm going to give you. Because this next question is going to see whether we really understand these relationships. So get ready. Here we go. 2 girls have to share 40 sweets. Yeah, and they are sharing these 40 sweets in this ratio. I take 2, you take 3. All right, that's how they're sharing it, in the ratio 2 to 3. Okay? Yeah, that's ratio. Just as how you do. Every time I take 2, you take 3. Huh? You wouldn't do that. You would want to turn it around. Every time I take 3, you take 2. All right, but they're sharing this ratio 2 to 3. The question is, how many sweets will the first girl get, and how many sweets will the second one get? Take a few seconds to figure it out. Every time the first one takes 2, the second one takes 3, or they shared it in the ratio 2 to 3. So how many sweets the first one get, and how many sweets the second one gets? Take a few seconds and put your thoughts together on paper. Someone is ready? Okay. All right. Let me hear you. What do you have as your answer? Yes, the one who's collecting 2.
She got 16.
She got 16. So we're saying 2 to 3 is equal to 16 to
24.
16 to 24. So you're saying the first girl will collect 16 sweets in total, and the second one 24 sweets in total. Do you agree with her?
Yes.
Yes.
Yes, and someone else had their hand up? Everyone else agree with her?
Yes, sir.
Good. Let us see, a much more detailed way, mathematical way of coming up with this 16 and this 24. Because let me tell you, I'm going to share a secret with you. Let me tell you, I was looking at somebody's book, and this is what the person was doing. I'm not calling name though, right? So the person can't say anything. But this is what the person was doing. The person had, this isn't wrong, you know, but it takes a lot more time. The person had girl A, girl B, and they had, this one get 2, this one get 3, this one get 2, this one get 3. And they counted up until they total up the 40, And then they add up all of this down here to see how much this one gets, and all of that down there to see how much. Now that way will help you to get the answer. But the only thing, it will take long. Because imagine if this 40 was 4,000. Right? Imagine if the 40 was 4,000. All right? Good. So we wouldn't want to continue to use this approach. And some persons looking so guilty like it's more than one of you. All right. So this is what we do. We say, look, every time the two of them take from this pool of sweets, they will be taking a total of 5. Every time they take, they will be taking a total of 5. So what we will say is that let us call this 5, this first 2 as the person's share, and that 2 as the other person's share. So we can say the total share is 2 plus 3, which is equal to 5. So what we need to determine now is how many this first person will get. And this first person is getting 2/5. Remember, the total is 5. 2 plus 3 is 5. So they're getting 2 out of 5. And the second one is getting 3 out of 5. So how do we write it as a fraction? We say 2 out of 5 of the total sweets. So it's much shorter. So it's 2 out of 5, or 2/5 of 40. And we work this out. 5 into 5, 1. 5 into 40, 8. 2 8s gives us 16, which we had there, correct? The second person is receiving 3 out of 5, so we say 3/5 of 40. So we say 5 into 5, 1, 5 into 40, 8, and 3 8s, 24. And we get our answer very fast. So we don't have to go ticking and, like that. Is that clear?
Yes, sir.
Good. You sure you understand this?
Yes.
And we're going to close off this lesson by giving you one to do by yourself. And you're going to take 10 seconds to answer it. Anybody think they could take 10 seconds to answer it? Huh?
No.
No. How much time you want?
20.
20 seconds. Good. Somebody say 20 seconds.
15.
No 20 first words counts. So if you have 500 to be shared, in the ratio, let us say in the ratio of 3 to 7. 500 is to be shared in the ratio 3 to 7. How much will the first person get? How much will the second person get? Who's finished? 10 seconds. Yes. We have someone finish here. Yeah, what is your answer?
150 to 350.
150 to 350. So you're saying this is equal to 150 to 350. Is there anyone who agree with her? The others who had up their hand?
Yes, sir.
You agree with her. So a few persons agree with you. So that's a good sign that they agree with you. It means that it could be correct. But what we will do, we will verify that she is correct. What is the total share every time these two persons take?
10.
10, yes. 3 plus 7 will give us 10. So we can say the first person gets 3/10 of 500. And we say 10 into 10, 1. 10 into 500, 50. And 3 times 50 is 150. So far, so good. Correct. 150 we have there. The second person is getting what fraction of the 500? 7/10. So it's 7/10 of 500. 10 into 10, 1. 10 into 500, 50. And 7 by 50 will give us 350. So you're quite in order. Perfect. Good. So that's how we can share. So any quantity you have, you can share it. Right? So if we have $10,000 to share between me and Harish in the ratio of 9 to 1, well then I will be able to calculate. Yeah, ratio of 9 to 1. I'll be able to calculate how much I get and how much Harish gets. Alright? So we stop there. Let us just summarize what we did in today's lesson though. What we look at is ratio. That's our main topic. We look at the topic of ratio. We say what ratio is. Ratio refers to the comparison between two quantities, right? Yes, between two quantities. We focus mainly on these numbers. Comparison between two numbers. There's a special symbol we use for ratio. The colon. Yes, we use the colon. We also look at reducing ratio. Oh yeah, we can look at reducing a ratio, and then we also look at how we can express or we can divide a quantity using a given ratio. So we can reduce it, and then we can also use a ratio to break up a given quantity. So we look at those today in class. So at least I know today that I learned a little more about ratio and how to divide numbers using a given ratio. Is there anyone who learned something about ratio today?
Yes, sir.
Good. And I also know that I enjoyed this class, and I look forward to seeing you again for the next class. And I hope you are looking forward to the next class as well. So what you will do is go home and you will pick up your textbook, your Mathematics for Secondary Schools in Guyana book 2. You will pick up your textbook and you will find the topic ratio, and you're going to answer 2 of the questions in the whole exercise. 2 questions you're going to answer? How much questions do you think you should answer? All good. And you answer all the questions in that exercise, and you come prepared for the next class. Any questions you have though? I have some very bright students. So we have no questions for today. Well, then I will see you next time. Bye-bye.